Okay. Let's let everything get warmed up, and then we will start. In fact, let me do something real quick. Be right back. Okay, I need a throat lozenge. So, this week, if I can get this mic to sit straight. Okay. If anyone can't hear me or things are weird, let me know. So this week is the deep dive and review. Essentially what we're doing is going through and we're seeing what we've done in the last 6 weeks, where we can expand and improve or kind of challenge our own thinking and our approaches. Yesterday we did a little bit of refactoring and a little bit of extending what we already have, and I think that worked well. So let's just pick up where we left off yesterday. Build error. Yes. So, if we go into our carpenter, we had done this little bit of refactoring so that we could get access to how much an action costs in terms of stamina. Give me a second. My other laptop with the chat wasn't online, so if anyone said anything in the last 5 or 6 minutes, I did not see it. Okay. I'm still living on a stream, so if you can hear this throat lozenge bounce around in my skull, my mouth places, just let me know, and we will never do that again. So, I created this map because I'm a huge fan of dictionaries for looking up things and exposing information. I think it's really concise and it's fast, right? It's, just kind of a fancy hash table. So it works well for these types of things. We're backing this property, which is something you're going to hear a lot in the C# community, that you can back a property with a field. So this is what we call a field, just a variable with no getter and setter. And this is what we call a property, which is essentially a variable with a getter and a setter. Okay, so where this comes in handy is when you want to do something as a computational step to the property that's being exposed, but maybe internally you don't want to have that same either restriction or formatting or whatever have you. So it does come in handy quite often. Okay, so we take immediate advantage of this inside of our actions by saying adjust stamina for this actor by the amount of stamina that's in the map. And so by doing this inside of our base actor, you're going to start doing all these fun checks for things like, can the player even respond, or do they have enough stamina? And this is an extension of this is an implementation of refined abstraction of our command pattern. So it looks very similar to the same abstraction that we see inside of the hive mind. Look very similar because they are very similar. And this is where the design pattern lends consistency to our code. Doing very similar checks. We take the request, we grab our type, our sender, and our target out. Then we check our states, and if everything looks fine, we'll go ahead and we'll process the action. And then as our next step, like, so we're kind of passing this off, right? So we've got these two, not to get too geeky, but like these two stargates, right? Or these two ends of a wormhole. And it's coming in through this, our hive mind, and it's got to have a very similar or contractually agreeing endpoint on the other side. And so that's where we have this guy. And again, it looks very, very similar. So we break out our game type and create a new game response. We don't really care about the target here, and we assume that the sender is me, right? I'm the person that requested this. Okay. So, am I exhausted? Am I disabled? From either of those two things, say can't respond. And then I say has enough stamina for action, and return whether or not, if I don't have enough stamina, I'll return not enough stamina before I ever get into the fight or anything like that. And we tried that and it worked. But we need to extend this over to our other classes. So let's cheat. Let's grab these two things. And this is a bit redundant because we don't have a base class, right? We don't have a base player class that we can kind of share functionality between. So since we only have a contract, every class is responsible for implementing its own members and methods, which is, and a lot of times, a good red flag for if we find that your contract is causing a lot of duplicate code, maybe go ahead and upgrade to a abstract class so you can bake in that functionality and then have your other implementations derive from it. Okay. So attack, heal, repair, and negotiate is 1, 3, 3, 3. So 1, 3, 3, 3. Let me replace this with that. Okay. I'll tell you what we'll I'm thinking. Do we have a way to make this even cleaner? Kind of, we won't worry about it. Like I said yesterday, we're going to take that first painful step of doing everything by hand. So we're constantly thinking about it as we're doing it to make sure that our next step is going to be the right one. But I think we'll find that we've got a pretty cool opportunity to refactor this using maps. Okay. Looks very, very similar. Let's go over to our player for a second. So, when we fight, we're doing action strategy attack, this plus boost. It all seems fair and pretty straightforward. Negotiate does the same thing. Okay, we'll leave that alone. But a plan is forming. A plan is forming for this. Mechanic. Mechanic is 2312. Nothing exciting, but it's the less glamorous side of coding. Okay, medic. All right. Come up here, grab this guy. So, in my mind, right now, I'm thinking to myself, I could make this better. Hang on. 3122. And I'm fighting that. I'm fighting that desire because we don't know where things are going to go. We aren't really that confident about how these things are going to change. And even before, when we started doing some other refactoring, we really are kind of guessing. And with more experience, those guesses become more educated and less prone to becoming anti-patterns. But as a point of humility, very smart people, smarter than you or I, write bad code. Eshkatite says hello. Hello, Eshkatite. Glad you made it. So, people that are much smarter than you and I write bad code. And the design patterns can't save you from it. Well-written style guides can't save you. It's going to happen. So I try to keep myself humble and to say, don't refactor prematurely, because what looks great now, especially when so many other parts of the application have to evolve, what looks great now might change drastically in the next iteration. So my rule of thumb, if you see me refactor other places and then you're hearing me now say that I'm going to hold off from refactoring because that might be a mistake, the logical question you're going to ask yourself is, why is now bad and other time good? And that is a fair question. And essentially, for me, if I still have a lot of work to do in an area, I'm going to hold off on refactoring. So we refactored a bit in our factory for the player. We refactored a bit some other places. I'm getting ready to show you another refactoring point, and it's because I feel somewhat confident that that area of the game is about as complex as it's ever going to be. And that assumption is where I could be wrong. And that, I think, is how good programmers still manage to write bad code. And it's just, there really is no way around it. You're going to be, just as you get better, as you improve your personal software process,